Hello and welcome back for another VMK in the math series. In this VMK, I'll be describing the spherical coordinate system. You're probably already familiar with the Cartesian coordinate system, which is the standard x, y, z coordinate system that you're first taught in high school. Well, the spherical coordinate system is another way to represent points in 3D without having to use x, y, and z. Instead, we have three other values that we use to represent the point in 3D space. And these are usually represented by a distance called rho, or what I'll be using is r, and two angles, which I'll call theta and phi. As far as I know, I don't think there is a universal rule for how these three coordinates are defined with respect to x, y, and z, so you can define these to suit your specific application to make your spherical calculations easy. Now, before I go into the actual math of the spherical coordinate system, let's go and take a look at how the spherical coordinate system can be used to represent points in 3D. Okay, what I've done here is set up a x, y, and z coordinate system. The way it's defined is the red line here represents the x-axis, and positive is going from the origin, which is located right here, all the way out to this end. The y-axis is defined by the green line here, and positive starts at the center here and goes backward, and z-axis starts at the center and goes straight up. So if I wanted to define a point that is located 1 unit in the x, 0 in the y, and 0 in the z, that point would be located right here. And this is a three-dimensional graph, so you can see as I rotate around, we see that these axes are sort of fixed, and the definition of the coordinate system is shown here on the scales along the outside edges. They're not labeled on these axes here. Now, you should see a sort of thicker line here on the x-axis, and that just represents a line of 1 unit length that is right now laying on top of the x-axis. Now, this video is to focus on the spherical coordinate system. So instead of using x, y, and z to define a point in 3D space, what we can do is define it using one of our three new coordinates. And again, as I said before, we're going to use r, theta, and phi. Actually, let me go into Photoshop here and write this out. So for the spherical coordinate system, we're going to have three coordinates. We're going to have r, we're going to have an angle theta, and we're going to have another angle called phi. R is a distance, which is going to tell us how far from the center our point resides. So going back to their diagram here, if we wanted to represent this point here, this would be the distance from the center outward, which in our case is 1. Theta and phi are two angles that we use to represent how far the point is with respect to a specific axis. So let's first talk about the theta angle. If we change the theta angle, what's going to happen is our point, which is currently located here, it's going to rotate around the z-axis, and the z-axis is pointing up. So it's going to go around in a circle, and it's going to stay on the xy plane. Let me draw a picture here to show you what I mean. So for it to draw a circle here on the red and green axes, and as I rotate this around, you'll notice that that circle is perfectly flat. So we're sitting here on this plane, and if we change the angle theta, what we're going to be doing is taking our one point and just rotating it about our z-axis, which means we're going to be rotating it around and causing that point to move around in the circle, like so. So we see, as I'm increasing the angle theta, the angle from the x-axis here is increasing, which is causing our point, which is located at the end of this line here, to move around in a circle. So just by defining this one coordinate, the theta value, we can tell where our point is going to be in 3D space along a circular path. Now we also have a second angle here, which I call phi, and that one represents how far our point is away from our z-axis. Or in other words, we have another circle that we can rotate around, and this circle you can see is standing up vertically. This one is now in the xz plane, so if I look at it this way, it's perfectly thin, and it's going to represent how much we can move our point upward as we're changing the angle. So as we're changing the angle, you can see we can cause our point to move upward out of our plane, or out of our XY plane, like so. And now by the combination of, well, I should also mention here that our other coordinate here was r, and just by changing the value of r, what we're going to be doing is increasing the length of this line here or decreasing. So in effect, shrinking or enlarging these circles that I've drawn here. Now, by combining the values for r, theta, and phi, what you can do is then fully define a point in 3D space. So you can see here, for instance, if I were to have some sort of offset in phi, and then change the angle in theta, instead of moving around the circle here that's on this plane, we're going to be moving around in the circle that's higher up. Or I can continue doing that so we can fully create this sphere. And in essence, the reason why this is called the spherical coordinate system is because all of the points will sit on a sphere as you're changing the values for theta and phi. If you're keeping your r value fixed, you're going to just be moving a point around on a sphere. This spherical coordinate system is really good whenever you're trying to define objects in 3D space that either move along a curve or are representative of something that moves around on a bowl or a sphere or something along these lines. It's a lot easier to calculate the three-dimensional position of an object in 3D space on a sphere using spherical coordinate system as opposed to using the XYZ Cartesian coordinate system. And let me show you why. Let's just rerun the simulation here where I have the first circle here. If I wanted to say my point that I'm interested in is going to move around in a circle, well, if I wanted to define that point in XYZ Cartesian coordinates as it's moving around in the circle, I need to calculate some formulas to figure out what is the x value, what is the y value for the different change in time. So as the point is moving around in the circle, the x, the y, the z will be changing because that's just inherent of the Cartesian coordinate system. However, if we use the spherical coordinate system to represent the exact same motion, we don't worry about changing three variables. Instead, we're just changing one. In this case here, if we're moving along this curve, we're just changing the angle theta because theta represents how a point moves around on this plane. If we know that our point is going to be moving vertically in a sort of circular path, then we're just changing the one variable, which is phi. And phi represents now how this point is defined in 3D space without having to worry about the other coordinates. So the reason why you'd use a different coordinate system as opposed to the Cartesian coordinate system is really based on the application that you're working with. So this is how r, theta, and phi are grouped together. Now just to finish everything up here, let's go back into Photoshop and I can write out some formulas here for you. Okay, let's go into Photoshop here and take a look at the relationship between the spherical coordinate system values. So if we were to have our circles here that I drew before, and let's say we pick on a point somewhere on the sphere here. Let's say that this point here is somewhere on the sphere. If I were to take a line and connect it to that point, we get something like so. And then if I were to take this point and project it straight down until it hits the XY plane, it might land over here, let's say. Now this point also I can connect up to the origin like so. So now we have something to be used when defining the values for r, theta, and phi. R is the length of this distance from the origin out to the specific point that I'm interested in. Theta represents the angle from the x-axis. So let's say that this is our x-axis here, x-axis. Then it's going to represent how far away from the x-axis we're going to rotate our projected line here. And again, this line here represents this point's location in 3D space projected down onto the xy plane. This is y-axis. So this angle that is formed here we designate as being theta. Finally, the last angle value, which is phi, represents the distance that our line here is from our z-axis. So this is our z-axis. And this again is phi. So if we have a value of phi equal to 0, then that means we're going to be pointing straight up here along the z-axis. For this point here that I just drew, our three coordinates are theta phi, might be something along the lines of, let's say, r is equal to 1. Theta is some positive value, looks like 45 degrees. And phi is also some positive value, maybe let's say 50 degrees. So 145, 50 would be the coordinate value here for this point. And again, if we were just to take one of these angle values and just continually increase it, what will happen is this point is going to start traveling around in a circle. If we take theta and just continually increase it, then what we're going to get is this point is going to sort of sweep around in a circle like so, in a plane here, somewhere up in the upper hemisphere of this circle. If we take the phi value and just continually change it, what we're going to do is cause our point here to go from one pole to the next. So it's going to travel upward and downward sort of in a big circle. And r, if we change its value, it's just going to be sliding in and out along this line here. So that's what the spherical coordinate system is all about. Again, it's very useful whenever you're trying to define points in 3D space that are traveling on a sphere or on some sort of curved path. So I hope this was helpful, and if you have any questions, feel free to go to the website and located under the form section here, you can take a look inside of the Math VMK series, and in there you'll find that there's a link to this VMK. If you have any specific questions on the spherical coordinate system, you can go and post questions in there.